So good morning everyone. I am Dr. Rama, Assistant Professor of EC Department from Dr. MGR University. So today I will be reading about the topic Carnot map, which is another method of simplification of Boolean expressions. The Boolean expressions can be solved using Boolean algebra, which you have to understand the concept of Boolean laws, rules and theorems. During the process of simplification, we have to predict the successive steps. So for this reason, we can never absolutely certain that this is the simplest solution we have obtained in the process of simplification. So the method which we called as the map method is being proposed by range and then modified by Rama. And this map method was coined and it was called as the range diagram or the Carnot map, or in short we call it as the K map. So which is the K map or the map method is a graphical approach, the semantic approach of a graphical chart where it consists of boxes which we call it as the cell. So each box we represent a product term, and in case of your SOP and in case of your POS, each cell is being represented by a sum term. So in case of any logical function can be represented either as a truth table or SOP or POS form. So in case of two variables, so let us consider the logical function is going to have a two variables expression. In that case, how are we going to represent in this K map is, say for example 2 power 2, so which is 4. So for a two variable expressions, we are going to have 4 cells to represent it. So this is how we are going to represent. So in this case, for example, we have this is a two variable expression, logical function which is going to be represented. So let us consider for a two variable expression, we are representing a truth table. So 0, 1, 1, 0. So in this case, each box is called a cell and each cell is representation of a product term. So how we are going to represent in this K map is each row and the column will have a variable or its complement or a combination of variables or complements. So in case of a two variable system, this is the first box is or the cell is represented by 0, and the next box is next row of the box is A, which is 1, and again it is 0, 1, so which is B bar and this is B. Okay, so in this case, this is the representation or logical function which is going to have a K map. So how are you going to represent in the K map is, so wherever you have the ones in the truth table, we will be representing that in the K map. So let us consider this is 0, 1, 2, 3. This is your number. So in this case, this is 0, 1, 2, 3. So the first and your second is having the output as 1, 1. So that is how we are going to represent the cell. So in this case, and here it is representing your truth table output in your K map as 1 and 1. The remaining boxes or the cells are being represented as 0. So in this case, there is a plotting of K map where you will be grouping the ones and we will be finding out the expressions. As of now, in case of, say for example, we have 3 variables. A logical expression is going to have 3 variables. It can be represented by 8 cells. So either you can represent it as this form or it can be represented as in this case, this will be 0, 0, 0, 1, 1, 1, 1, 0. This will be 0 or 1. So in this case, you can see here, we have written here 0, 0, 0, 1, 1, 1, 1, 0. So as in case of our digital systems, we can change at a time only 1 bit. So in this case 0, 0, 0, 1, 1, 1 and 1, 0. So only one bit from 0, 1 you can change, only it will be retaining the 1 here, and only the 0 will be changed to 1. And then in the next step we will be having the retain the 1 here, and this 1 will be changed to 0. So only one bit can be changed at a time. So this K-map will follow the gray code sequence. Okay, so in this case, how it is being represented here is 0, 1, 0, 0, 0, 0, 1, 1, 1 and 1, 0, 7. So this is how it will be number in case of a vertical presentation, and in this case it is 0, 1, 3, 2, 4, 5, 7, 6. Okay, so this is how we will be representing the K-map in case of a 3-variable system. So next we will see how a logical function from a truth table can be represented in K-map. We will take a function, logical function is being represented by truth table. So like I have already told you, the logical function can be expressed either as a truth table or a SOP expression or a POS expression. So let us first take an example as a truth table. So let us consider a 3-variable system. Okay, so a logical function is having 3 variables. 0, 0, 0, 1. So what are, this is the combination. So for a 3-variable system, there will be 8 combinations. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So these are the, for a 3-variable system, 8 combinations. So say for example, this logical function is going to have an output of this form. Okay, so now we are going to represent this truth table in a K-map and get the expression easily. Okay, so in this case, as you already know, 0, 0, 0, the decimal equivalent is 0. For what is the decimal equivalent of 0, 0, 1? It is 1, it is 2, 3, 4, 5, 6, 7. So now we represent this truth table in a K-map. So as in this case, it is a 3-variable system. You need 2 to the power of 3, which is 8 cells. So let me consider, I will take A here. This is BC. So each cell is going to have a product. Each cell is going to have the represent the product term. So let us consider, this is A bar, this is A, this is B bar, C bar, this is B bar, C, this is B, C, this is B, C bar. Okay, which is nothing but 0, 0, 0, 1, 1, 1 and 0. So how are you going to represent in the numbering the cells? So this will be 0, 1, 3, 2, 4, 5, 7, 6. So now how are we going to represent this table here is wherever you have your outputs. Wherever this function is going to have the outputs as 1, we are going to project that here in your K-map. So in this case, one output is being obtained in the number 0. So represent as 1. So the next one is 2. Then it is 4, 5 and 7. Okay, so other cells are being represented as zeros. So this is how we are going to represent your truth table in your K-map. Okay, so next, so we have framed out we have represented the truth table in the your K-map. So how we are going to obtain the output? So there is another method which there is a concept called plotting of K-map. Okay, so how we are going to map is this. We can group it adjacent cells. So in this case, how we can get the grouping in the K-map is we can group only the adjacent cells either this way or this way. Okay, so in this case, this is how. So we can either pair them. Okay, either we can say for example we have a 1 here, one here, you can pair them. If you have 1 here, 1 here, okay, say for example you have a 1 here, you can make it as a quad. Okay, so for example you have so for example you have 1 here, you can make it as a object. So that is how you can group it and find the expression. So in this case, let us consider in this case. Say for example, in this case you have a 1 here and you have a 1 here and 1 in this sense. So how you are going to group it is, you can also group this one and make it as a pair. So let us consider, we group this, okay, and take it as group 1. Okay, so in this case this one and this one is adjacent. So we can group this and make it as a group 2. Okay, so next either, okay, so this one is remaining without pairing. So what you can do is either you can pair it with this adjacent one or you can pair it with this adjacent one. So in this case I can pair it, okay, I am going to pair it like this and this will form group 3. So now we will going to write the expression. So your output expressed as y is equal to, so how you are going to write the expression, each term is, so this is your group 1. Okay, so take it horizontally. What is common for both the cells? It is A bar. Okay, and when you take it vertically, what is common? Your C bar is common. So C bar. So this is your first term of your group 1. Next is your group 2. Okay, so as it is your SOP, it is sum of products term. Okay, so plus. Okay, so what is, when you take it horizontally, what is common to both? It is A. So when you take it vertically up, what is common in this? C. So this is the term for your group 2. So for group 3, this is the group, and so when you take it horizontally, this nothing is common. So it is A into A bar will be equal to 0. So sorry, A plus 0. Okay, it will be 1. So in this case, when you take it this way, you will be getting B bar, C bar. So this is the final expression of the logical function. So let us solve a problem which is having an expression of y is equal to AB plus AC plus AC bar. In applying your K-map, the expressions should have all the variables. That is what we call as the canonical form or the standard form. So only those, so each term in an expression should contain all the variables. Then only it can be represented in your K-map. So canonical form or the standard form. So when a problem is given in like this, we have to first convert it into a standard form, and then only you can implement it using a K-map. So how it can be done is y is equal to AB. So in this case, what is the term? So you can see here what are the variables present here: AB, AC, AC bar. So it can be either in a complement form or in the normal form. So in this case, AB and C. So it is a 3 variable expression. So in this case, each term should contain either in your complement form or in a normal form the variables. So in this case, what is missing? C is missing. So how are you going to represent in your SOP form? This is actually your sum of the products expression. So we are going to convert that SOP to a standard canonical form. So how it can be represented is C bar. Okay, to bring it to the standard form. So in this term, what is missing is B. So A into B plus B bar into C plus in this term B is missing. Okay, so we have to multiply by this expression C. So now we can bring it to the standard form. So we'll just multiply it. It is A, B, C plus this. You're going to multiply by this. So AB, C bar plus AB. Okay. Then AB into C plus AB bar C plus AB into C bar plus A B bar C bar. So you can see here you have converted the SOP, normal SOP, into a standard canonical form. Okay, so now this only can be represented in your K-map. So you have, when you are representing the terms in your K-map, it is easier to present them in terms of numbers, which we call as the min terms and max terms. So in case of your SOP expression, we can represent each term by min terms, which is represented as small m naught. In case of your POS, we will represent each term by max terms. In case of your POS, which we will be represented by capital M1 for easy representation in your K-map. So let us consider, say for example, you have a two variables. Let us consider we are having a two variable, and this is your output 0 0 0 1 1 0. Okay, and in this case it is having 0 1 1. And how we are going to represent in your min terms and max terms is, okay, so 0 is, okay, in case of your SOP, your 0 is represented as A bar and B bar, okay, which is M naught. Okay, in this case, your 0 1 is A bar B, which is represented as M1. Okay, in case of 1 0, it is A is 1 and B is 0. Okay, it is B bar, which is your min term M2. In case of 1 1, okay, it is A B. Okay, so which is represented as min term 3. So how are you going to represent in your POS, which is your max terms, is it will be 0 is represented. So in this case 0 is represented as A bar, sorry, A, and your 1 is represented as A. Okay, so in this case it is A plus B. As in this case it is your POS, each term is represented as A plus B. Okay, which is your capital M1. Okay, it is A plus B bar. Okay, 0 is represented as, okay, A, and 1 is represented as B bar. Okay, so in this case, which is your capital, sorry, 0, this will be 1. Okay, so in this case it is 1. So it is A bar plus B, which is your M2. Okay, so next is your A bar plus B bar, which is your M3. So this is how you represent your min terms and max terms in when you consider the truth table. Okay, so next we will see how we are going to represent this in a K-map. Okay, so in this case we now are going to represent this in a K-map. So as before simplification, you can see here ABC, and again you have your ABC. You know that A plus A is nothing but A. Okay, so now we are going to simplify this. Okay, A, B, C plus A. Again you can see here this term and this term is replicating. Okay, so you can write it as A, B, C bar plus A, B bar C plus A, B bar C. Okay, so this is your final expression. So how are you going to write? As in this case it is your min terms. Okay, you can represent in 1 1 1. Okay, which is your M7. Okay, next it is 1 1 0, which is your M6. Okay, this is it is 1 0 1, it is M5. Okay, and this is 1 0 0, which is 4. Okay, it is your M4. Okay, so see next how we are going to represent in your K-map. As it is a 3 variable system, you need 2 to the power of 3, which is 8 sets. B bar, C bar, P. Okay, so how do you represent it in your numbers? Okay, so now we're going to represent, okay, these terms in the K-map. So what are the terms which are present here? M4. So M4. So this is your, okay, 1. So which all terms you are having, there has to be represent your K-map as 1. Okay, then 5, 7 and 6. So others are there, okay, it has to be represented by zeros. Okay, so next what you have to do is you have to do the grouping. In this case you can see here all your ones are adjacent. So you can make it as a quad. Okay, so now how you going to write the expression y is equal to, in this case you can make it as a quad as all the fours are adjacent. Okay, so take it horizontally in this way. What is common in this? This A. Okay, when you take it vertically up, nothing is common. So in this case the expression output is y is equal to A. So this is how you can solve your problems using your K-map. Thank you.